Now we discuss about potentiometer. Here, potentiometer consists of a very long wire arranged on a wooden board such that the wire is of say some 5 to 10 meters length. Therefore, in order to reduce the space, it is cut into equal lengths of say 1 meter or so and are arranged side by side and joined by metal strips. So, you will get a continuous wire, resistance wire of uniform cross section and is connected to a battery through a variable resistance which is called a rheostat. So, by changing the resistance to the rheostat, current in the circuit can be changed and K1 is a key. Now, this circuit is called as primary circuit and the external circuit is known as secondary circuit. Potentiometer is a very versatile instrument used to determine potential difference very accurately and also to determine the interresistance of a cell. It is also used for determining the EMF of a cell in comparison with a standard cell. So, we will discuss first comparison of EMFs. Comparison of EMFs of two cells. Comparison of EMFs of two cells. The principle of a potentiometer is that the potential difference across the length of the potentiometer wire is constant. That is, if V is the potential difference between the points P and Q and L is the length of the wire, so this voltage drop per unit length is constant. So that is volts per meter or volts per centimeter. So this quantity is constant for every unit length of a wire, potentiometer wire. So that is called as principle of potentiometer. So whenever you are asked to write what is the principle of potentiometer, the potentiometer works on the principle of the potential difference across unit length is constant and it will not draw any current from external source. So because already there is a battery provided in the primary circuit, it takes current from this, so it won't draw any current from the external source and hence it is called as ideal voltmeter. So this is the principle of potentiometer. Now using this principle, let us see how to compare the EMFs of two cells. Two cells whose EMFs are say E1 and E2, they are connected to this first terminal P to a two-way switch as shown in the figure, and the third point of the two-way switch is connected to a galvanometer and the galvanometer is connected to a joint. So when you connect 1 and 3, E1 will come into circuit. So when you join 2 and 3, only the second cell will come into the circuit. Suppose you have joined the first point and the third of the two-way switch, then E1 will come into the circuit, current flows through this, the galvanometer, and say balancing point is obtained at N1. So the corresponding length of the potentiometer wire, so let us say this is L1. So to measure the length of this potentiometer wire, a scale is provided by the side of the wires. So L1 balancing length proportional to the EMF of the first cell. Similarly, when you connect point 2 and 3, the second cell is brought into connection and that balancing length, if suppose that is at L2 and balancing length is L2, then this must be proportional to the EMF of the second cell. Or you can write like this: E1 is equal to 5L1, E2 is equal to 5L2. So therefore, the ratio of the EMFs will be L1 by L2. So using this relation, EMFs can be compared. So if one of the cell value is known, the value of EMF of other cell can be determined using this relation. So this is how we compare the EMFs of two cells. The second application is determination of internal resistance of the cell. Internal resistance of the cell. So for this, the circuit, secondary circuit will change slightly. So here, let us suppose this is the cell whose resistance is to be determined, and here a suitable resistance is connected parallel to the cell. So let us suppose R be the resistance. The small resistance is connected parallel across the cell, and this is a key, and these two are joined like this. This is key to key. Now, when key is not introduced here, removed from this table, only cell E will come, of EMF E will come into the circuit. If the key is kept in the hole, the resistance also comes into the circuit. Now, the suppose only the cell is brought into the connection without inserting this key here, then only cell will come into contact and corresponding balancing point here, suppose N1, then we can say this E is proportional to the obtained balancing length, say N1. Now suppose key is introduced here, then a current will flow in the circuit and the potential difference changes. The potential difference across the resistance or across the cell. So it will be somewhat like this. So a resistance are joined to a cell with intermissions like this. So a current will flow like this. Say if it is I, then potential difference between these 2 points is equal to IR. R, if E is the EMF, R is the interresistance, that is also equal to, V is also equal to E minus IR. So because the battery is discharging, so therefore we can write like this. Suppose V is the potential difference across the resistance or across this E, and the balancing point is obtained at some point N2. The corresponding length of the resistance wire is L2. Then this must be equal to L2. Therefore, E by V is equal to L1 by L2. So let this be equation 1. Now we know from Ohm's law P is equal to across the resistance capital R, P is equal to IR. Now across through the cell the same current is passing, therefore I can write like this. E is equal to R plus B is equal to E minus I into small r, because when the battery is discharging it is losing volts. So in 2 ways we can represent this voltage. Therefore from this formula V is equal to IR, therefore I can press V by R. Therefore E is equal to V is equal to E minus in the place of I will write this V by R into small r. I will take this minus V by R into small r to the side. V plus V by capital R into small r is equal to E. So V common 1 plus small r by capital R is equal to E, or 1 plus small r by capital R is equal to E by V. So let us call this equation 2. Now if you see 1 and 2 and you can equate them, therefore 1 plus small r by capital R is equal to L1 by L2. So therefore small r by capital R is equal to L1 by L2 minus 1. Hence small r is equal to capital R into L1 minus L2 by L2. So this is the formula for interresistance of a cell. So if you know the balancing lengths L1 and L2, and if capital R is known, then you can find out small r using that relation. So this is another important application of potentiometer. So this is a very important long answer question. with this, the chapter current electricity is completed. Okay.